For part 3b, we ultimately want to find the transformation matrix representing this compound transformation from the left side to the right side. And we'll go through two strategies. So the first is a bit cumbersome, but you can get the right answer out of it. We're going to pick one of these options for sequences of elementary transforms and multiply out their individual transformation matrices. So we're going to start with the example 1, where we have three transformations: a scaling of the x dimension by -1, rotation by -45 degrees, translation, then final rotation. And then all I've done here is written out multiplication of some of these matrices. So here this is evaluating these sines and cosines. This step multiplies together these two matrices just because they're simple to multiply together. Then I multiplied together these two matrices, and finally did the final multiplication to get out one transformation matrix. But this could be error prone, and it's a little bit tedious. Another strategy is to look at this picture from the coordinate transform perspective. So instead of keeping the coordinates fixed and then transforming the object, you can also see it as where's the new coordinate frame. So let's say that the origin is originally here at 0, 0. Now the origin is at 2, 2. And this basis vector in red for the x-axis has now become a new axis, let's say u-axis, -1 over square root 2, -1 over square root 2 vector direction, so it's normalized. And we're going to call that vector u equals this. The y-axis has become this v basis vector. And this origin is the origin O. So putting these together into one transformation matrix, T equals U, V, origin, and then pad it out for homogeneous coordinates with 0, 0, 1. And so we can expand this transformation matrix as -1 over square root 2, -1 over square root 2, 0. Then copy in the basis for v, -1 over square root 2, 1 over square root 2, 0. And then finally the origin at 2, 2, finally 1 to complete the homogeneous transformation. And this is the answer, and it could save you a lot of time compared to matrix multiplication.